All right, good morning, everybody. Today we're starting the 9th week of school. That means we're on the backside. We're going to finish up chapter 13 today. Today, first thing we're going to talk about is the slope of a line. What is a slope? What constitutes a slope? If you had to say it in words, what constitutes a slope? I know we use the word, but we don't know how to define it. The best way to define a slope is rise over run. It's typically how people define slopes. What that means, what the rise over run means, is the vertical change of the line that's going up or down over the run is the horizontal change. And the bottom always goes to the right. In other words, if the slope is positive, it goes up and the bottom always goes to the right. If it's negative, it goes down and it always goes to the right. So here we have vertical change and horizontal change. When we say change, what we mean there is the difference. The difference more so between two numbers. Okay, we know that the vertical is the y-axis or the y values. And the horizontal is the x-axis or the x values. So let's look at this. If we had two numbers, 3 and 7, how far are the changes? How far are those two numbers apart? They're 4. How about 2 and 96? How far are those apart? How'd you get 94? Yeah, so what we got 4 is 7 minus 3. 96 minus 2. So it's the first and the second number here. The difference is always the second number minus the first number. So no matter what two numbers we have, it's always the smaller minus the larger minus the smaller, the second number minus the smaller number. So it works no matter what. It's the second number minus the first. So if I had any two generic numbers, x sub 1, that means the first x point. X sub 2 means the second x point. What would be their difference? It's the same concept as these other ones. It would be x2 minus x1, the second point minus the first point. Same thing with the y's. We have a first y, then we have a second y value. The difference between those are y2 minus y1. Those define the difference between the first x and the second x, the first y and the second y, the first number and the second number. All right, let's look at this. Let's look at some points. How many points do we need to have a line? 2 points. This is the x-axis, and this is the y-axis. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. So I'm gonna have 2 points. Those are my 2 points. If I connect them, then I have a line. If I connect them, then I have a line. So this is my first point. This is my second point. How do you know it's the first point? Because when you start off at 0, the first point you get to is that one. The second point you get to is that one. So what's the location of the first point? 1, 1. It's x1, y1. And the location of the second point? 5, 4. So those constitute the locations of both of those points. Okay, now since this is the first point, then the x value of the first point is 1. The y value of the first point is 1. And this is the second point. So the x value of the second point is 5, and the y value of the second is 4. So each point has an x and y component, and those x and y components are defined that way. So we have slope. It's defined as rise over run, or more so the vertical change, and over the horizontal change. In mathematics, the word change is represented by the delta sign, the triangle. Since the vertical, those are the y's, the change of y over the change of x. So what's the formula? What do we know is the equation for the difference of the change of y? Well, we did that earlier. If y1, y2, the difference is y2 minus y1. So the top part is y2 minus y1 over the change of x, x2 minus x1. And since we're dealing with symbols now, we don't write the word slope anymore. The letter M represents the slope. So whenever you see the letter M in algebra, you know that means slope. And you know that's the equation, y2 minus y1, x2 minus x1. Now, any 2 points on a graph defines a triangle. It starts at 1, goes to 5. Starts at 1, goes to 4. It creates a triangle, a right triangle. Well, the horizontal change is 5 minus 1, which is 4 units apart. The vertical change is, the second point is 4 minus 1, which is 3. So that's what we're talking about when we talk about change. Let's label these x1, x2, y1, y2. What is x1? Yeah, x1 is the x value of the first point, which is 1. x2 is the x value of the second point, which is 5. Y sub 1 is the y value of the first point, which is 1. And y sub 2 is the y value of the second point. That's what the subscript here means, which point it belongs to and what value is it. So the y value of the second point is 4. So if we take these as we defined them and plug them into our equation, y2 is 4 minus y1 is 1 over x2, which is 5, minus x1, which is 1. So the slope, 4 minus 1 is 3, 5 minus 1 is 4. The slope is 3 over 4, which is what we found here. The vertical change over the horizontal change. That's what it's saying us. What that means, what the slope tells us is this. From the first point to the second, remember this is vertical, it's positive. So from this one, we go up 3 spaces. 1, 2, 3. Now we go to the right, 4 spaces. 1, 2, 3, 4. That's how we go from first point to the second point. And that's what it tells us. It says go up 3 spaces, and that's why the bottom is always to the right. All right, let's look at some more examples. So in other words, once we have 2 points defined, we label them, plug them in, and that tells us the slope. Tell me the slope of this line. And try to make it as, it's not a trick question. It's just, it's supposed to be close to those points I can. So it's the first thing you have to do after draw the picture. The first thing you have to do, the farthest to the left is your first point. That's point 1. And this is point 2, the farthest to the right. Point 1 is made up of y1, x1. Point 2 is made up of x2, y2. So what is x1? What's the x value of the first point? -2. And the y1, the y value, is 3. So that location is -2, 3. And likewise in point 2, we have to go to the horizontal first. 1, 2, 3. So it's 3. And then down 2, -2. So if you're given a graph, first locate the 2 points that you're dealing with, write them out, label them x1, x2, y1, y2. So what's x1? Yeah, x1 is the x value of the first point, which is -2. x2 is the x value of the second point, which is 3. y1 is the y value of the first point, which is 3. And y2 is the y value of the second point, which is -2. Since we're asked to find the slope, and you plot, they got the points, and you labeled them, let's put down the formula. y2 minus y1 over x2 minus x1. I wrote down. So what is y2? y2 is -2 minus y1 is 3. x2 is 3 minus x1 is -2. Whenever you have a negative number and you're plugging in, always put parentheses around it, because we have to separate those two signs for right now. And we know here, negative times a negative becomes a positive. So we have -2 minus 3. So they're both negative. The answer is negative. 2 plus 3 is 5. 3 plus 2 is 5. So our slope is -1. Actually, it's -1 over 1. Because what this thing says here with the negative, it says that since it's negative from the first point, from point 1, go down 5 spaces. That's what that says. And then go right 5 spaces to get to the second point. To get to point 2. That's what it's telling us. So from point 1, from 3, you go down 5. 1, 2, 3, 4, 5. That puts us here. Then you go over 5. 1, 2, 3, 4, 5. And that's what this tells us. But it simplifies to this. We can go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So it's going to be the same thing. We can use either of these two slopes. They both mean the same thing. The slope is -1. Find me the slope between these 2 points. All right, so look at this. Since we're looking for the slope, we know we need y2 minus y1 over x2 minus x1. So always start off by writing the formula down. Since this is our first point, this is point 1 and this is point 2, because that's the way it's written. That means this number here is the x value of point 1. This is the y value of point 1. The x value of point 2, the y value of point 2. And that's why it's always easier if you label them and write them down. Because once you have them labeled like this, then there's no messing up. X1 is -3. X2 is -4. Y of 1 is -5, and y of 2 is 7. So the slope is y2, which is 7, minus y1, which is -5, over x2, -4, minus -3. First, you can't have two signs next to each other, so we have to fix those. Negative and negative becomes a positive. Negative and negative becomes a positive. So our equation now becomes 7 plus 5, -4 plus 3. Top 7 plus 5 is 12. Since the opposite signs, 4 is bigger, it's negative. 4 minus 3 is 1. Negatives go to the top, so this becomes -12 over 1, which makes it -12. That's my slope. Yeah, but now you have to remember, what does this mean? That means you go down 12 and over 1. So it's always, yeah, but we always write it as -12. Good job. You got it. Okay, so you see, finding the slope is just plug and play. You have two points, x, y components of each. Just plug and play. Now, there are special cases. There are special cases. We have horizontal lines, and we have vertical lines. Horizontal lines go left and right. Looks like the horizon. Vertical lines go up and down. Now, if we had, well, let's look at the slope. What do you think the difference of the slopes are? Well, let's see. If we had an X and Y graph here, and an X and Y graph here, and I had 2 points. So we know that's a horizontal point line, and that's a vertical line. What are the points? What is the location of point 1? -1, 2. And the location of point 2? Yeah, it's 2, 2. So this is point 1, this is point 2. Likewise, let's do the same thing over here. This is point 1, this is point 2. So what's the location of point 1 here? That's supposed to be at 2. 2 and 2. There. And point 2? Two and -2. If a line is horizontal, what do we notice about the 2 points? No. I mean, I could have used these 2 points. I could have used that point also. So what do you notice about the 2 points? What do they have in common? Do they have anything the same? What value is that? Horizontal lines have the same y values. What about vertical lines? Yeah, these have the same x values. So if you look at 2 points, if you see the graph, it's pretty easy. If it's horizontal, it's horizontal. If it's vertical, it's vertical. But if I give you 2 points and you notice that the y values are the same, then you could tell that that's a horizontal line. If the x values are the same, then you have a vertical line. Okay, let's pretend we don't see that. Let's look at the slopes. y2 minus y1, x2 minus x1. And the same thing for the vertical slope. y2 minus y1, x2 minus x1. So this is the x value of the first point. This is the y value of the first point. This is the x value of the second point. This is the y value of the second point. Likewise on the other one, on the vertical ones. X value of the first, y of the first, x second, y second. So let's plug in the values for the horizontal lines. y2 is 2 minus y1 is 2. x2 is 2 minus x1 is -1. And 2 negatives become positive. Two minus 2 is 0. 2 plus 1 is 3. And while we're at it, let's do the other one. Y2 is -2 minus Y1 is 2. X2 is 2 minus X1 is also 2. -2 minus 2 is -4. 2 minus 2 is 0. So what's the difference? 0 over 3. 0 divided by 3. How many times does 3 go into 0? 0. So that one's 0. If the 0 is on top, the answer is 0. How many times does 0 go into -4? Yes, it does. It goes infinitely. If I promise to give you nothing, how many ways can I do that? I can give you, yes, yeah, infinite ways. So that's why if it's 0 on the bottom, it's undefined. So if the slope is 0, what do we know? You have the same y values, and it's a horizontal line. All those three are synonymous. If I have a horizontal line, that means I know the y values are the same. I know my slope is 0. If my slope is undefined, then I know I have to have the same x values. And I have a vertical line. And the equations of the lines are just as simple. If I have the same y values, then my equation of my line is whatever my y value is. In this case, it's 2. Since both of my y values are the same, that's the equation of my line. My vertical line, since all the x values are the same, since the x values are 2, the equation of my line is x equals 2. It's whatever the same values are. Those are the equations of the lines. So we have 4 possibilities here with slopes. What are they? The first one. What kind of line is that? If you saw a line like that, what kind of line is that? What kind of slope does it have? As x gets bigger, so does the y values. That's how you can tell if it's a positive slope. As x gets bigger, y goes down. That's what we call a negative slope. If the line goes left and right, that's a zero slope. And if it's a vertical line, then we know we have an undefined slope. Those are the only four slopes we can have. Now, we can also determine what the slopes are from the equations of the lines. These first two have the same structure. Whenever you have an equation with two variables, solve for y, and whatever's in front of your x is your slope. So an example of this one would be because this slope, whatever's in front of the x is your slope, since it's positive, the graph will look something like this. It's going to go up to the right. And a negative slope, if the coefficient of x is negative, it'll look like that. Remember, slopes are always fractions. This one is go down 3 and over 1. Go down 3 over 1. We can even say the third one. Remember, if it has a zero slope, if the slope is 0, we're left with that. Y equals some number b. It's the y-intercept. B is the y-intercept. So in this, whatever value that is, that's also value of b. That's your y-intercept. And for undefined slopes, it's just whatever the x-intercept is. The x-intercept. There is no y value there. All right. Tell me the slope of that line. Tell me the slope of that line. Nope. To find the slope of a line, you have to solve for y first. The coefficient of x is your slope. So what's the first thing you have to do in that equation? I'm solving for y first. I got to move 6x over. So 2y equals negative 6x plus 10. Then what? Then what do I do? Yes, is y by itself? What do I have to do to get y by itself? Divide each term by 2. Negative 6 divided by 2 is 3. 10 divided by 2 is 5. So my slope is negative 3. It's the coefficient of x. So remember, first one you have to solve for x, get y, I mean solve for y, get y by itself. It cannot have a coefficient. So that you get rid of the coefficient. Okay, let me give you another one. Find me the slope. And also tell me the y-intercept. All right, to find the slope, what do we have to do first? Solve for y. So in solve for y, what do I have to do first? have to get y by itself. So what do we get rid of? The 2x. You have to give anything that's plus or minus to the y. So negative 5y equals negative 2x plus 4. Since there's a negative in front of the y, change all the signs. So from negative 2x becomes positive 2x. Positive 4 becomes a negative 4. Yeah, you can go ahead and divide by negative if you want to, but chances are you'll make more mistakes that way. Change the signs first, and then next step is to get y by itself, we divide each term by 5. So what's my slope? Look at your notes, see where the slope's located. Look at the steps I put in the last question. Where's the slope located? To find the slope, solve for y, and where's the slope? No, the coefficient of x. It's the number in front of x is the slope. So your slope is positive 2/5. The y-intercept is the constant, because whenever you have an equation and you set x equal to 0, it disappears. What you're left with is the y-intercept. So the y-intercept is at 0, negative 4/5. Let's do one more. Tell me the slope and the y-intercept. Let me make it even better. I'm going to add 2 to the second. There. All right, what's the first thing I have to do? Remember, my objective, I have to get what by itself? The y. So here's the y. There's no y there. So what do I have to get rid of first? The plus 2. I subtract 2 from both sides. I cannot subtract 2 from this one because this one doesn't have an x. It's not like terms. So those cancel. I have negative 2x. They're both negatives. 6 plus 2 is 8 equals negative 2y. I have a negative in front of the y, so I change all the signs. Positive 2x, positive 8, positive 2y. And then what? I'm trying to get y by itself. Yep. Divide everybody by 2. So y is equal to x plus 4. So what's my slope? What number's in front of X? 1. Or you can say 1/1, up 1/1, up 1/1, but it's the slope is 1. What's my y-intercept? Yeah, because you find once X is 0, then you have which is 4. That's your y-intercept. When X is 0, the constant number is always your y-intercept. In an equation, the constant, once you get y by itself, the constant is always the y-intercept. So far, so good. Want to do another one? Okay, do one more. Let's make it 4. 5y minus 4. Same thing. Find me the slope and the y-intercept. First step. We have parentheses. You never want a parenthesis in the equation, so get rid of the parenthesis first. Distribute. Positive, positive. 2 times 3 is 6. X. Positive times positive is positive. 2 times 4 is 8. Remember, order of operations, do special. Since you can't do anything inside the parentheses, we have to get rid of it. After you get rid of parentheses, always combine like terms. So positive 8 minus 4 is positive 4. Just 8's bigger than 4. The answer is positive. 8 minus 4 is 4. Now we get rid of the 4. Since we're trying to get y by itself, we have to get rid of the 4. We add 4. So we have 6x positive. 4 plus 4 is 8. Then we divide all 3 by 5. Very good. So y is equal to 6/5x plus 8/5. The slope is 6/5. Very good. And the y-intercept? Zero 8/5, right? That should be straightforward from there. So now that was just looking at one line. Let's compare 2 lines. When you have 2 lines, 4 things can happen. when you have two lines, four things can happen. And here are those four things. The two lines can be what we call parallel. The symbol is that. Two lines never touch. That's one thing that can happen. This is line 1. This is line 2. The two lines never intersect. Since they never intersect, you have no solutions. Because when you have two lines, it's where they cross. Those are your solutions. They can be the same line. The line 1 and line 2 could be exactly the same. There you have infinite solutions. Because each point is a solution. You can have two lines just cross somewhere. No special orientation, they just cross. That we call other. Just and the last one is where the two lines create a 90-degree angle. That's what that little box there means. It means a 90-degree angle. When that happens, those are called perpendicular lines. And the symbol for that is an upside down T. And yet you only have one solution. There's line 1, there's line 2. So those are the only four things that can happen when you have two lines. They can be parallel, they can be the same line, they can be perpendicular, or they could be some other orientation. All or nothing, and then these only have one solution. But how do we tell them apart? If I give you two equations without graphing them, how do we tell them apart? By what? Yes, or anything more from our equations? What do we notice from our equations? What have we been talking about? Slopes. What do we notice about the slopes of these two lines? In the parallel lines, what do we notice about their slopes? Yeah. The slope of line 1 equals the slope of line 2. So if the slopes are the same, they could be parallel. But what about if they're the same line? What are their slopes? If the two lines are the same, what about their slopes? They also have to be equal. They're the same lines. How do you tell those two apart? How do you tell the difference between the same lines and parallel lines then? Let's pretend these are our graphs. We know the slopes are the same. The slopes are the same. But what distinguishes these two pictures? What are those called? Remember, this is the y-axis. This is the x-axis. Those are the y-intercepts. If they're parallel, they have to have different y-intercepts. So we use letter B. The intercepts cannot be the same. B is equal to the y-intercept. So if two lines are parallel, that means that their slopes have to be the same and their y-intercepts have to be different. If they're the same line, then their slopes are the same and their y-intercepts have to be the same. If those are true, then there's the same line. So for parallel in the same lines, we have to look at both the slopes and the intercepts. Perpendicular lines. On this side, the slopes are different. This side slopes are the same. These side slopes are different. In this one, if it's perpendicular, the slopes have to be negative reciprocals of each other. We'll talk about that in a second. The slopes have to be negative reciprocals of each other. And that if they're negative reciprocals, in other words, they have opposite signs and they're just flips of each other, then they're perpendicular. We can't say anything about the y-intercepts because they can cross in the y-intercept. So all we care about is the slope. In the other one, only thing we know is the slopes of the two lines are not the same. If the slopes are different with no special orientation to them, then we know we'll have one solution and that's it. So let's look at this. I'm gonna give you some slopes. You give me the slope that's parallel to it and give me the slope that's perpendicular to it. Remember the two parallel lines, that's parallel, that's upside down T is perpendicular. So here's the first one. If the slope is 2/3, what's the slope of the line parallel to it? Yeah, has to be the same because if they're parallel, they have the same slope. What's the slope perpendicular to it? Remember, it has to be negative reciprocals, negative flips. So it has to have opposite signs. So it's negative. Flip this one. Yeah, so the perpendicular is -3/2. if the slope is -4? What's the parallel slope? -4, it's the same. How about the perpendicular? You're right, almost. Because this is already 4/1. You have to flip it. You are so close. Parallel should be easy by now. What's the slope parallel? 0. So what's perpendicular slope if it's 0? What is 1/0? Undefined. Very good. Because this is 0/1. And 0 doesn't have a sign, so you can't change sign, just 1/0, which is undefined. You cannot have 0 on the bottom. Very good. -4/5. -4/5. Very good. Very good. So those are how we tell if two lines are parallel or perpendicular, looking at their slopes and their y-intercepts. So what we're looking at here is this. This is called the slope intercept form of a line. Y equals mx plus b. Because m is your slope and the b is your y-intercept. Okay, tell me if these two lines are parallel, perpendicular, or neither. Are they parallel, perpendicular, or neither? So work this not together. What do you have to do first? You have to solve for y. Yeah, you have to solve for y. So in the first case, we have to subtract x from both sides. -x plus 4. And then divide by 2. So there's a 1 in front of the x, so it's -1/2 x. 4 divided by 2 is 2. Because there's a 1 right here in front of the x. Same with the other equation. Subtract x from both sides. 2y equals -x minus 6. Divide by 2. -1/2x minus 3. So what do we know? To determine them, we have to first look at the slopes. So what's the slope of line 1? It's whatever's in front of the x. The slope of line 2? Also -1/2. Since the slopes are the same, what can we say so far? They're either parallel or the same lines. Do we know which one's which? If they're parallel, what has to be true? If they're parallel, the slopes are the same, but the y-intercepts have to be different. If they're the same line, the slopes are the same, the y-intercepts are the same. So we have to compare the y-intercepts now. What's the y-intercept of 1? 2. Yeah, and the line of 2 isn't. Are they equal? No. So since they're not equal, but the slopes are equal, then they are parallel. They're not the same lines. The 2 lines are parallel. Let's look at these next 2 lines. X plus 2y equals 4. 2x minus y equals 6. Tell me if they're parallel, perpendicular, or neither. So solve for y for both of them. First one, get rid of the x. 2y equals -x plus 4. Divide each term by 2. It's -1/2x plus 2. There's line 1. Now line 2. Subtract 2x from both sides. -y equals -2x plus 6. Change the signs across the board. Y equals 2x minus 6. So what do we notice about the 2 slopes? What's the slope of line 1? What's the slope of line 2? So what do we notice about them? They're not the same, but how are they related, if any way? This is -1/2. This is +2/1. So they have opposite signs. They're flips of each other. That tells you they're perpendicular. Because to be perpendicular, you have to have 2 things. Different signs. Flips of each other. So if you have that, then it's perpendicular. Let's do one more. we have 3x minus 7y equals 35. 7x minus 3y equals negative 6. All right, the first one. Let's get y by itself. So we subtract 3x from both sides. Equals negative 3x plus 35. Change the signs. 7y 3x minus 35. Then what? Divide by 7 to get the y by itself. Divide each term by 7. Y equals 3 over 7x. 35 divided by 7 is 5. Do the same thing the other side. Solve for y. Subtract 7x from both sides. Negative 3y equals negative 7x minus 6. Change the signs. 3y equals 7x plus 6. Divide by 3. Y equals 7 over 3x plus 2. So what do we notice about the slopes? What's the slope of the first one? First one is 3 over 7. The second one is 7 over 3. So what's their relationship? But are they parallel, perpendicular, or neither? Let's see. If it's parallel, what has to be true? The same slopes, and they're not the same slopes, so they're automatically not parallel. Perpendicular, they have to be flips, but they have to have opposite signs. They're both positive. So since it's neither of those, it's neither. In other words, these two lines are going to cross someplace, one place, and that's it. That's all we can tell about it. All right, so that's once you solve for y, then you can see what the slopes look like, and then if the slopes are the same, compare the y-intercepts. In word problems, in real-world applications, instead of the word slope, we use the average rate of change. Because in application problems, we deal with time. Whenever you deal with time as one of the variables, then you have to use average rate of change. It's the same equation. It's just that the words change. Here's an example. In 2006, there were 33 million customers doing whatever. And in 2011, there were 46 million customers. Find the average rate of change of customers per year. In 2006, there were 33 million customers, and in 2011, there were 46 million. Find the average rate of change. So the average rate of change y2 minus y1, x2 minus x1. It's the slope. Average rate of change is a slope. But the difference here is instead of x, we use time. So instead of x, we use time. So in the first thing, in 2006, we had 33 million customers. 2006, that's the period of time. So that's the x component. And the y component is the 33 million. And the second one says in 2011, we had 46 million. So the time is 2011, and we had 46 million customers. Just find the slope between those 2 points. X1, X1, Y1, X2, Y2. So what's Y2? Y2 is the Y value of the second point. Here's the second point. There's the Y value. So it's 46 minus Y1, the Y value of the first point, 33. Time 2 is 2011 minus 2006. $46 minus 33, 13. 2011 minus 2006, or 11 minus 6. 5. So 5 goes into 13 how many times? With how many left over? 3 over 5. 3 over 5 is the same thing as 0.6. Because 5 goes into 30 6 times. So what does this mean? What's the change of customers? What's the change of customers? No, it went up. It went up 2.6 million customers per year. So that's what it's saying. Since it's a positive number, it went up. This is per year. That's what average rate of change looks for. Can you do another one? Or are you okay with it? Another one, or are you okay with it? Another one? All right. In 2006, I had 65 million drops. And In 2011, I had 58 million drops from my classes. What is the average rate of change of drops per year? Oops, sorry. These are called average rate of change. Whenever you deal with word problems, whenever you deal with time, a year is a time. So in this year, we had 65 million. In this year, we had 58 million. So those become our points. In 2006, because it's time is always the x value. And whatever else we have is the y value. So the time is the x, anything else is the y value. So this is our first point. This is our second point in our graph. Every point has an x and y component. So this is the x component of the first point. This is the y component of the first point. The x component of the second, y component of the second. Yeah. Since this is time, we can say it's time 1 and time 2. So the average rate of change is simply the slope. y2 minus y1 over x2 minus x1. Or since we deal with time, y2 minus y1, t2 minus t1. So now we just have to plug and play. What is y2? 58. It's the y component of the second point is 58. Minus y1, it's the y component of the first point is 65. Time 2 is 2011 minus time 1, which is 2006. $58 minus 65. It's going to be negative. So 65 minus 58 is -7. -7. 2011 minus 2006, 11 minus 6 is 5. 5 goes into 7 once with 2 left over. 5 goes into 20 4 times. So it's a loss of 1.4 million drops per year. So we have 1.4 million drops each year, fewer drops each year. That's that. That's section 3.3 or 13.3. Now we're going to start getting into writing, actually writing equations. So far I've been giving you equations. Now we're going to determine what the equations actually are, and we're going to learn how to graph them too. But first, let's look at the graphing them. 13.4, writing and graphing equations of lines, which I will simply call EOLs. So if I gave you 2 points, 2 points of the line, and I ask you to graph those, graph that line, one, two, three, 1, 2, 3, 4, -1, -2, -3, -4. So to graph these, what do? Just plot them. Go to 1, that's the X, go up 3. That's 0.1. Go to 2, down 4, that's 0.2. Connect the dots, and there's my graph. So if I give you 2 points, just plot the 2 points and you're done. That's the easiest way. Graph the line with slope equals 3/4 going through -1, -2. Now I'm giving you a point and a slope. So make our chart here, our graph. -1, -2, -3, -2, -3, -4. So if I give you a point and a slope, the first thing you have to do is plot the point. So if given a point and slope, then first plot the point, and second follow the slope from that point. So I got to plot the first point, -1, -2. So -1, there's my point. So according to this, I plot the point. Next, from this point, I follow the slope. What does the slope tell me to do? The top number, since it's positive, it goes up. The bottom number always goes to the right. It's always supposed to be positive. So from this point, I go up 3. 1, 2, 3, and over 4. 1, 2, 3, 4. There's my second dot. Connect the dots. And I'm done. There's a line. Okay, next, I'm giving you the y-intercept and a slope. So we make our chart. In order to draw a graph, we have to have either 2 points or a point and a slope. Do we have a point and a slope? What's the point? Yeah, the y-intercept, -2. So we put a dot there at the y-intercept at -2. What's the slope? Tell me to do. The slope is 5, so it's 5 over 1. From this point, I go up 5. 1, 2, 3, 4, 5, and over 1. Connect the dots, and I'm done. Graph that one. What form is this equation in? This equation is in the form y equals mx plus b, which is the slope-intercept form. What does m stand for? What does b represent? The y-intercept. So if I give you the equation in slope-intercept form, always plot the point first. Plot the y-intercept, whatever that is. 1, 2, 3, 4, 5. From that point, follow the slope. The slope is -2, so it's -2 over 1. Down 2 over 1. To your next dot and connect the dots and you're done. Yeah, so if I give you an equation, I don't care what it looks like, solve for y, and then whatever's in front of your x is your slope, and whatever at the back is your y-intercept. Graph that equation. What do I have to do first? Solve for y. So get rid of 3x first on both sides. Oops, subtract 3x. So 4y equals -3x positive 8. Get rid of the 4. Divide each term by 4. Eight divided by 4 is 2. All right, we solve for y. Now we have to graph it. Where do we start? Yeah, at the y-intercept. So the y-intercept is at 2. Go down, very good. 1, 2, from this point, go down 3 spaces, and then to the right 4 spaces. Very good. So we go down 3 to the right 4. Very hard. Okay, those were graphing ones. Now we're going to get to writing the equations of the lines. For right now, we're only going to be using the slope-intercept form. Okay, if I give you a graph, can you tell me the equation of that line? To find the equation of line, we need 2 pieces of information. A point, usually the y-intercept, and the slope. So what do we know about this line? Do we have the y-intercept? 1, 2, it's -3. So the y-intercept is at -3. 0, never 3. What's the slope? What's the slope? From this point, how do I go to this point? 1, 2, 3, 4, 5. 1, 2, 3, 4. It's 5/4. Just always from your y-intercept, your first point, to the next point. So your equation, the slope is 5/4 x, and the y-intercept is at -3. There's your equation. Find that equation of the line. Since my graphs are horrible. Oops, I forgot to press record. Oops. So we had the y-intercept is 4. Our slope is down 7/4. So our equation is -7/4 x plus 4. So now I'll give you 2 points. Find the equation of the line going through the point 0, 3 and 5, 9. To find the equation of the line, you need a point and a slope. Do we have those? What's the slope? We can, if we have 2 points, we can find the slope. So y2 minus y1, x2 minus x1. Y2 is 9, minus y1 is 3, x2 is 5, x1 is 0. So the slope is 6/5. Do you know the equation already? Remember, we want it in this form. What are we missing? The y-intercept. How do we find it? I'll show you the easiest way of finding this one. Point it. That's the y-intercept. 0 number, that's the y-intercept. So our answer is 6/5x plus 3. Because that is the y-intercept. Find the equation of the line with slope equal 4 going through 1, 3. Find the equation of the line with slope equals 4 going through the point 1, 3. I want it in this form. So what are we missing in this equation to find that final answer? Do we have m? Yeah, that's the 4. Do we have b? No. Do we have x and a y? Right here, x and a y. So why don't we just plug them in there and solve for b? So the y is 3, m is 4, x is 1. We don't know what b is. Four times 1 is 4. Subtract 4. B is equal to -1. So we solve for B. We know what M is. M is 4. Just plug and play. Put those values in. Let's do another one. So if I give you 2 points, then you find the slope. And then you pick one of the points and solve it. Let's do another one like this, and we'll do with 2 points. Equation of a line with slope -2 going through -1, 4. -1, 4. Okay, we want it in this form. What's y? What's m? X? -1. We have to find b. Negative is a positive. 2 times 1 is 2. Subtract 2. B is equal to 2. M equals -2. So our answer is -2x, +2. If I gave you 2 points, what would you do first? Find the equation line going through those 2 points. We have 2 points. What do we miss? What are we missing? What 2 things do you need for equation of a line? A point and a slope. Do we have a slope? No, we have to find it though. y2 minus y1, x2 minus x1. So here's x1, y1, x2, y2. So y2 is 9, minus y1 is 5, x2 is 7, minus x1 is 3. 9 minus 5 is 4, 7 minus 3 is 4, so my slope is 1. So I have a slope, but I have 2 points. I only need one. So pick either one you want to that's easier to work with. Pick the first one. Or this, it doesn't matter, it's gonna give you the same answer. So I have my slope is 1, and I'm gonna use the 0.35. Plug in that equation. Y is 5. Slope is 1. X is 3. And we're solving for B. One times 3 is 3. Subtract 3. B is equal to 2. Now just put in what we know. 1x plus b, which is 2. There's my answer. That's the line that connects both of those dots. There's another method we could use. Let's look at this information here. We have slope is -2 and the point is -1,4. And we know that's the answer. Slope is -2 and the point is -1,4. Since we're given a point and a slope, we can use something called the point slope form. We've been using the slope intercept. The point slope form looks like this. Can you guess where that came from? What equation is that? What is M? Slope. So this is, I just wrote this backwards, so it just looks different. Whenever you have fractions and equal signs, you want to get rid of the fractions, right? So what if I multiplied both sides by x2 minus x1? These would cancel. That's where I get that from. I get it from the slope equation, but I have to keep an x and a y. So there's my x and y has to stay there. X1, Y1 is the point I plug in there. So what's Y1? What's my Y value? 4. Slope is -2. And x1 is -1. So since I have a point and a slope, I use the point slope formula. Negative and negative becomes positive. I distribute. Negative times positive is negative. 2 times x is 2x. Negative times positive is negative. 2 times 1 is 2. and I add 4 to both sides. Four is bigger, so it's positive. 4 minus 2 is 2. It's the same answer, just gone about a different way. What form is this? This is slope intercept. Because there's a slope and there's a y-intercept. This is the point slope form. Because x1, y1 is a point and m is a slope. x1, y1 and a slope. This is the slope intercept. There's your slope and there's your y-intercept. The third equation is the standard form. The standard form of an equation is when you have x and y on the same side and a number. So all the variables to one side and all the numbers on the other. The only stipulation is A has to be positive. So let's look at here. Put that now into standard form. Here's my answer in slope intercept form. Put it in standard form. So to put this in standard form, what do I have to do? I have to put x's and y on the same side. So I have to add 2x to both sides. So 2x plus y equals 2. There it is in standard form. And you don't want fractions. A is an integer. A and B are integers, no fractions. In other words, if we had put that into standard form. So put that in the standard form. All right, in order to put it in standard form, what's the first thing we have to do? Get rid of the, remember, there's another rule we had. Whenever you have fractions and an equal sign, get rid of the fractions. That rule came first, and that's always going to be never subtract and add with fractions, because now you're going to double up your work by adding stack of fractions. Let's first get rid of the fractions. What's the LCD? 12. What do we do with the LCD? Each term by the LCD. It's the same 5 steps. Find the LCD, multiply each term by the LCD, reduce before you multiply, the 3 goes into 12 how many times? So we have 4 times 2y. The 4 goes into 12 3 times. We have 3 times x. Now we just have a straight equation. We multiply to get rid of the parentheses. 4 times 2 is 8. 3 times x. Negative positive is negative. 12 times 2 is 24. Since we want it in standard form, what do we have to do at this stage? Yep, 3x, yeah. So notice there's no more fractions. So we subtract 3x from both sides. So negative 3x plus 8y equals negative 24. Are we done? Why not? You're right, is no, we're not done. Nope. We have no fractions. We have x and y on one side, but a, the leading term of x, has to be positive. So we change the signs. Change the signs across the board. And there's our final answer in standard form. Find the equation of line going through point 57 that has slope 0, undefined slope. Find the equation of line going through those two conditions. We talked about this not too long ago. If a slope is 0, what does that mean? What kind of line do we have? The slope is 0, we have a horizontal line. If it's a horizontal line, then the equation is simply the y value, is the y-intercept. If the slope is undefined, it's a vertical line. It only crosses the x-axis. So it's the x value. We just talked about it about half an hour ago. All right, we're almost out of time. They get here 11:50. What time do we get out of here? 10:50, yes, so let's just call it a day here.